Think, learn, innovate.
Hi everyone. Today's topic is transient response of RC circuit with DC input. This is present in your basic electrical course of first year, first module. And what we'll do is we'll charge our capacitor. So we'll find out the charging equation of capacitor and we'll see what will happen when that capacitor is fully charged. So our topic today is transient response of RC circuit with DC input. So first of all, I will draw the RC circuit. I have a R here, I have a C here, and I will apply a DC voltage to this RC circuit. And this is my R, and this is my C, and the voltage drop across R is VR of T at certain time interval T, how much it will be, and it's V of C of T. And this is my voltage applied here. What I will do, I will say, okay, the KVL equation of RC circuit as shown in the figure, I will apply V, I will get a VR and I will get a VC. So this is your KVL equation. So what is my VR equation? Actually, VR equal to I into R. And what is my VC? We all know that the voltage across capacitor is 1 by C integration I dt. And I can write down what is my I. Actually, my I is nothing else but dq by dt, the rate of change of charge. I will not take the minus sign here. I will take the full magnitude of the current. And so I can write down V here. And so this is my equation number 1. I will write Ri plus 1 by C integration of I dt. I will plug the value of my dq here. So I got dq by dt plus 1 by C integration dq by dt into dt. So this equation now will look like this: R dq by dt plus q by C. So I will multiply both sides by C. So if I multiply this left hand side and right hand side by VC, so I got VC into RC dq by dt plus my q. Now we know that the total charge that can accumulated in the capacitor can be represented as q equal to v cv. So I will write down this one as a q naught. So my final question, I can write down q naught is equal to rc dq by dt plus q. So that's my equation number 2. Now I have to solve this equation. So I will go to the next page and I will try to solve the equation. So first of all, what I will do is I will bring my q naught in this side, and so my equation becomes minus rc dq by dt, and it becomes q minus q naught. So I can write down this equation in this format: dq q minus q naught is equal to minus 1 by rc into dt. So I will do the integration on both sides. And the limit of integration is very easy. We will say that the charge of the capacitor is 0. And initially it's 0 charge. So at t minus 0, the charge is 0. So at 0, when the time is 0, the charge is 0. When I bring the time t at certain interval of time, your charge will be qt. So if I solve this equation, if I do this integration, I will get ln Q minus Q naught, and that gives me 0 to Qt, and that is 1 by RC minus T. If I plug in the value of this one, what I get? ln, first of all it will be Qt minus Q naught minus ln, next is minus Q naught is equal to minus 1 by RC T. So log A log B gives me ln Qt minus Q naught minus Q naught minus 1 by RC T. So this, and if I take this thing in the previous case, so what I get here is Qt minus Q naught divided by minus Q naught equal to e to the power minus 1 by RC T. So next step will be Qt minus Q naught equal to e to the power minus 1 by RC T. So finally, the charging of a capacitor equation Qt is equal to Q naught 1 minus e to the power minus 1 by RCT. So this is the equation which represents the charging of a capacitor. So this is the charging of a capacitor equation. Now if I get the charging of a capacitor equation, I can find out the total current flowing through the circuit and the voltage drop across R and voltage drop across capacitor. So first of all, I will find out the current flowing through the circuit. So I will write down the current flowing through the circuit. So that gives me I is equal to dq by dt, that is nothing else d by dt of q naught 1 minus e to the power minus 1 by RC t. So if I do this derivative, I get I equal to q naught. So this minus minus comes away and I will come here by 1 by RC. And I got e to the power minus 1 by RC t. What is my q naught? Well, in the previous slide, we have seen that the q naught is CV. So I'll write down that thing here. So I equal to CV 1 by RC e to the power minus 1 by RC t. So this CC goes away. Actually, this CC goes away and I get V by R. So what is my V by R? It's very easy. My V by R is I0. So it gives you I0 e to the power minus 1 by RC t. So this is your current flowing through the circuit. So when I get the current flowing through the circuit, my next job is to find out the voltage across capacitor and voltage across resistor. So I will say voltage across the resistance. If this is a voltage across resistance, so I will say VR at a certain interval of time t is equal to, what will happen? VR equals to IT, which I got in previous case, into R. What is my IT? Just few minutes back I got it V by R into R into e to the power minus RC t. So I got this equation, and if I take this R and R out, so what I got V e to the power minus 1 by RC t. So that is the voltage across resistor. Now resistance actually. Next we will find out the voltage across the capacitor. So this voltage across capacitor is very easy. We know that the charge, which I found a few minutes back, is given as 1 minus e to the power minus 1 by RC t. And we know that Q naught equal to CV. So Q naught by C gives me V. So I will divide both sides of this one by C. So what I get? VCT, the voltage across capacitor, is V1 minus e to the power minus 1 by RCT. So what we see here, that we got the charge, the current, the voltage, everything we have got it. So what are the formulas which got it here is VCT, which we have got it. And here we have got it, the current, we have got the charge, and VR and VC. So we have got 4 equations. Now we will find out the value of these 4, means value of the voltage across resistance, the charge and the current at time t equal to RC. So I will take the time, I will say at t equal to RC. We will see that t equal to RC is called the time constant of the circuit. So if I find out the charge at t equal to RC, we will see that it will be around Q naught 1 minus e to the power minus 1 by RC into RC, and that gives me Q naught 1 minus e to the power minus 1, that gives me Q naught 1 minus 0.368, and that gives me 0.632 Q naught. It says that 63% charge buildup occurs at time constant t equal to RC. See the voltage equation same, so I can directly write down voltage VC t equal to RC. Same, it will be 0.362 VC. So I can write down the voltage across RC. It will be same equation, so it will be 0.632 of V. And what will be the current? Actually, the current, I'd say, I equal to T equal to RC is equal to I naught e to the power minus 1 by RC into RC. And that will give me I0 e to the power minus 1. That gives me 0.368 I0. So from the above values, we can draw the characteristics. So there will be 3 characteristics I can draw. First of all, I will draw, say this is your charge at certain interval time with respect to time. I can write down the voltage build-up in the capacitor. So V of C, voltage build-up with respect to time. And I can also draw the current which is going flowing to the circuit with respect to time. Now what will happen is, see, Qt. What is the equation of Qt? I know Qt is equal to Q naught 1 minus e to the power minus 1 by RCT. What is VCT? Vc of t is equal to V 1 minus e to the power minus 1 by RCT. And what is IT? Is equal to I0 e to the power minus 1 by RCT. So if t is 0, so it's 0. And so it will follow an exponential path like this. And it will steady rise. This is also the same equation, so it will follow the same path. It will follow the same path. Following the same path means that both the equations are same. And so if both the equations are same, it will follow the same characteristics actually. Because if I plug in t here 0, t0, e to the power 0 is 1, 1 minus 1, 0. And if I plug in t equal to infinity, so this becomes what? E to the power minus infinity 0. So the final value will be V. In this case, the final value will be I0. So it comes like this and it steadies. Here, if I come here actually, if t is 0, I get the maximum value. If t is infinity, I get 0. So it will start from Okay, and it will come back and put to 0. So if this is my equation now, so see, at this case, the steady state occurs. So this is the steady value. At least if I increase my current time, the voltage remain constant. That is, voltage means what the value of voltage? Charge V0. Similarly, in case of voltage, same thing what happens in the case of charge, the voltage remains V. This is called your steady state. And this is called your transient. Now, at t equal to RC, time period, say t equal to RC, how much voltage I am getting? I am getting 0.6 V, and at time period t equal to RC, what I am getting? 0.63 Q naught. So, if this is the case, if this is my voltage, whatever I am getting here, and what I am getting here, and whatever I'm getting here. So this is this part is called transient, where charging takes place and it is totally charged. Now from the above three equation, what I'm seeing here, at steady state, the voltage across the capacitor becomes maximum, and at steady state, the current here, the current becomes zero. So we can conclude from the above calculation that at steady state, in case of RC circuit, the capacitor becomes open circuited and the current flowing to the capacitor becomes zero. Okay. So this way we can have a charging of our inductor, means voltage build up in inductor, RL circuit, and then we can, another equation we can have that we have charged this capacitor, we can discharge it. So in future videos, I will try to bring all those calculations. Thank you. Have a nice day.